Hey everyone, and welcome. Today, we're tackling a LeetCode problem called maximum number of operations to move ones to the end. We'll break down the problem, figure out the logic behind it, and then walk through the code. Let's get started. Alright, so the problem gives us a binary string. That is, a string made up of only ones and zeros. Our goal is to figure out the maximum number of operations we can perform to move all the ones to the right end of the string. So, what exactly is an operation? Well, we can only do something when we see a 1 immediately followed by a 0. When we find this pattern, we can take that one and start moving it to the right. It keeps going until it either hits the very end of the string or it bumps into another one. That whole journey, from its starting spot to where it finally stops, counts as just one single operation. The question asks for the maximum number of operations. This means we want to count every single one of these move until blocked sequences that we perform on our way to getting all the ones grouped together at the end. Okay, let's walk through an example to make this clearer. Imagine our string is 1, 0, 0, 1, 1, 0, 1. To move all the ones to the end, they're going to have to jump over the zeros. Think about it like this. That very first one needs to get past the block of 2 zeros right after it. To do that, it has to perform one operation. Now once it's over, we have a group of 3 ones, followed by a 0. All 3 of those ones now need to jump over that last 0. Since each one performs its own operation to get past that block, that's 3 more operations. So we add the first operation to these 3, giving us a total of 4. Just a quick heads up, we'll be walking through the solution using Python, but don't worry if that's not your main language. The logic is the same everywhere, and I'll be showing the full code for Java, C++, and JavaScript towards the end of the video. The best way to solve this is with a greedy approach. As we scan the string from left to right, we'll just keep a running total of how many ones we've seen. The magic happens when we hit a 0. Think of it like this. Every time we find a new block of zeros, it acts like a hurdle. All the ones we've collected so far have to jump over it. So we just add our current count of ones to our total answer. In our example, we first see 1, 1, then a hurdle of zeros. That's one operation. Then we collect 2 more ones, making our total 3. Then we hit another 0 hurdle. All 3 of those ones have to jump it, so we add 3 to our answer. 1 plus 3 gives us the final result, 4. Okay, we've talked about the big picture and the logic. Now let's see what this looks like as actual code. I'll put the full solution up on the screen first. And don't worry, after that, we'll walk through the most important sections together. Alright, here's the Python code for our greedy approach. Don't worry if it looks like a lot. We're about to break it down piece by piece. First, we set up our variables. Ans is our final answer, which starts at 0. Ones count keeps track of the ones we've seen so far, also starting at 0. And I is just our standard pointer for moving through the string. We loop through the string using our pointer I. If the character we're looking at is a 1, it's simple. We just add 1 to our ones count and move on to the next character. Now for the important part. If the character is a 0, it means we've hit one of those hurdles. First, we add our current ones count to our total ans. This represents all those ones performing an operation to jump this hurdle. After that, we use a little inner loop to skip past any other zeros that are part of the same block, so we don't double count the operation. This logic also handles edge cases really well. If the string is all ones, we never hit a 0, so the answer is correctly 0. If it's all zeros, our ones count is always 0, so again the answer is 0. And if zeros come before the ones, no operations are needed, and our code correctly returns 0. It's pretty robust. So how efficient is this? For time complexity, we only pass through the string once, so it's big O of n, where n is the number of characters. That's really fast. And for space, we only use a handful of variables, so it's big O of 1, or constant space, which is as good as it gets. Alright, that covers the main solution in Python. As promised, for those of you who code in other languages, I'm about to show the full solutions for Java, C++, and JavaScript. I won't be breaking these down, so just pause the video on your language of choice to check it out. Alright, as promised, here is the full solution in Java. You can pause the video here to take a closer look at the implementation. Next up, here is the C++ version of the solution. Again, feel free to pause and review the code. And finally, here is the solution in JavaScript. Hopefully, seeing it in a few different languages helps solidify the concepts. So let's wrap it up. The best way to solve this was a simple and fast greedy approach. The real aha moment is realizing that you don't need to simulate the moves. Instead, you can just think of each block of zeros as a hurdle that all the ones you've already seen need to jump over. It turns a tricky-sounding problem into a simple counting exercise. Alright, Before we jump into the other languages, I want to quickly show you a personal project I built to solve a problem that always drove me crazy. It's an app called My Daily To Do. My biggest frustration with every other to-do app was retyping the same things every single day. Go to the gym, review code, work on the daily LeetCode code problem. You know the drill. So I built my app around one simple but powerful idea: separating your routine tasks from your one-off tasks. Routine tasks, marked with the little refresh icon, automatically reset for the next day. One-off tasks, like ship new feature, get the little puff of smoke icon, and they disappear for good once you're done. This small change turns a dumb checklist into a smart scheduler. If that sounds useful, you can try it right now on the web. The link is in the description. And one more thing I want to make super clear. Right now, as a thank you for being an early supporter, the app is 100% free. There are no ads, and no subscriptions whatsoever. This means you get access to everything, including really powerful features like presets, which let you save entire task lists and load them with a single tap. Now, down the road, creating new presets will likely become part of a premium plan to help support the channel. But, and this is the important part, any presets you create now, while it's all free, are yours to keep and use forever. So it's the perfect time to check it out on the web, play with all the features, and build out your perfect setup at no cost. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more LeetCode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Also, if you're looking for even more LeetCode problems beyond the daily challenge, I've started a second channel called LeetCode Unlocked. It's where I'll be posting solutions to a ton of other problems, so if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this LeetCode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. If you want to support the channel, a few people have asked how I plan my solutions. I'm a big fan of sketching out the logic and data structures on a tablet before I code. It really helps. I've put affiliate links in the description to the tablet I use, and a few other good options. Using those links doesn't cost you anything extra, but really helps me out. Or, if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.